right around the corner coming up on Sunday. Wise guy Matt Sellen from the University of Illinois with us this morning, and we're talking about the physics behind the football.
Right, and so it just so happens that the semester that the class that I'm teaching just started last week, and the first thing we talk about are trajectories and kinematics and things like that, which relate directly to what you observe when you see the football flying through the air. So I thought I could tell you some things so when you watch the game, you can watch it kind of like I would, like a real nerd like me. Okay? And so there's some really interesting measurements you can make just by kind of estimating stuff and to see if the physics works out right. So what you want to be able to do, like for example, if you want to know how fast somebody's throwing a pass, it's easy to do that because there's lines on the field that sort of tell you how far apart the people are.
Sure.
And if you just measure how long it takes the ball to go from the quarterback to the receiver, let's say, if you take that distance and you divide it by that time, then you have the speed.
Okay. Feet, meters, yards?
Well, so what you want to do, since you have yards on the field, yard is like 3 feet.
Sure.
So if you just take the yards, multiply by 3, and divide by the time. Now, measuring the time is a little tricky, so I'm going to teach you how to do this, okay?
Okay.
So the way I do this is like, some people count steamboats or whatever it is. I count bananas because you have the right number of syllables. So if you kind of look at your watch and you go 1 banana, 2 banana, 3 banana, sort of get the hang of seconds, right? And if you watch a pass go, you start that on 0 banana, 1 banana. So if you get to 1, that's a second, 2. But if you get to just a ba, that's a quarter of a second. Banana, that's a half a second. Banana.
I feel like I need like a little cheat sheet, like legend.
Right. But you can just sort of figure it out. So once you can kind of estimate the time in the air, so let's say that, for example, somebody throws a 10-yard pass and it's half a second in the air.
Okay.
Okay. So 10 yards, that would be 30 feet. Half a second would be 60 feet per second. And if you want to then turn that into miles an hour, the thing you do is you basically multiply, I wrote it down here, you multiply by 2/3, more or less. Okay. So you take 60 feet per second, multiply that by 2, it's 120, half of that is multiply by, I should have done this earlier, divide by 3, so it's 40. So it would be like 40 miles an hour, okay? So anyway, that's how you can do it in your head. Now, interesting thing is...
Yeah, sure.
Work on that.
But feet per second is a good thing, too. Okay?
Sure.
So you can,
I'm
that's an easy one.
going to bring some scratch paper to the Super Bowl to
now,
do this.
The other thing that's kind of interesting is is hang time, and that's the other thing that you can just measure. So, for example, if you watch a quarterback nail a pass really hard, it looks like that ball is going almost flat.
The frozen rope.
It looks like it's almost going straight, but it can't be going straight because gravity pulls everything down. Everything has to fall down at the same rate. So what happens is if anything that falls basically has to, in 1 second, it falls the same distance. In 1 second, it's going to fall down that far. It's going to fall 4 feet. Okay? If you drop something and 2 seconds later, it's going to fall 4 times as far. It's going to fall 16 feet and so on. Okay? So the way that you can figure out how far, if you know the hang time, if you just measure by this little counting trick that I'm doing, the way you figure out how high it must have gone, if you assume that you throw it and catch it at about the same height, the height it must have gone above that height, if you take the number 4, okay? Then you take the time that you just measured in your head, and you multiply that by itself, so you square it. So in other words, if it's 2 seconds, you square 2, you get the number 4. Then you multiply that by the 4 that you started with, that I said, so that would be 16. So if something has a hang time of 2 seconds, it must have gone 16 feet in the air. Okay? If it has a hang time of 1 second, it must have gone 4 feet in the air. And you can just check that. If I take this ball and I throw it up so that it's in the air about a second, 1 banana, 2, okay, like that, that's about 4 feet. In fact, it was 4 feet. Okay? So if you just, but the longer it takes, the amount of distance it has to go goes up by the square of the time. So in other words, if it hangs in the air twice as long, then it has to go 4 times higher. Okay? So, but that also means that if somebody throws, they're waving at me. Are we done? I'm sorry.
No.
Okay, good. I tend to go on.
Good.
So anyways, so if you have a pass that only stays in the air for, let's say, a quarter of a second, like it's a really, really short pass, the distance it has to go high is only like 3 inches. So it almost looks flat, right? So if you throw it maybe 10 feet, but it's really, really fast, it only takes a quarter of a second, it only has to go up and down 3 inches. However, if it has a hang time of 2 seconds, like I said, it has to go 16 feet above where it was. So that's why if you throw a long pass, they tend to be these things that go way up in the air and come back down. If you're kicking a field goal, right, you're trying to go really, really far, then the thing hangs long, long time in the air because it has to go way, way up and come way, way down again.
Right.
Okay? And so for short, fast passes, looks flat, but it's not flat. Okay, so that's the other thing you can do. Now, the other thing is when you're kicking a field goal or you're punting, You want the thing to go really as far as you can, usually.
Right.
And the way you do that typically is you kick it at about a 45-degree angle.
Sure.
Okay.
And so what happens is, in that case, you just work it out. It's pretty easy to work out that the distance it goes up is about a quarter as the distance it's going to go on the ground. Okay?
Okay.
So for example, if you want to kick the ball as
80
far as you
feet.
can down the thing, 80 feet, let's say, from where it leads your foot to where it touches the ground, then it's going to go about
20 feet
in the air. Roughly speaking. I mean, it's just
Sure.
kind of hand waving a little bit like that.
Right.
Okay. So these are numbers to keep in mind. Well,
There
I
you
like
go.
numbers, right? Do we have time for one more little fact?
One more little fact.
Okay, one more little fact. If you have collisions between, let's say, a linebacker and a lineman, which
Sure.
happens every single play, okay? So say you got like a 220-pound linebacker rushing at the quarterback, and then the lineman jumps out in front of him to stop him. You like my jump?
Just
Okay.
like that.
All right, just like that. Now, these guys, they have something called momentum.
Right.
It's a product of their mass times how fast they're
Velocity, yeah.
going. And that momentum, if they collide and they stop, their momentum had to be the same. So suppose you're a 220-pound guy running at 6 meters per second, which is really, really fast, okay?
Okay.
Then if you're a lineman, you're a 330-pounder, that means you got, you know, 2/3 the mass of this other guy, or 3/2, like more. You don't have to run quite as fast to have the same
Right.
momentum. So you only have to run, let's say, 4 meters per second, which is still pretty fast.
Especially for a 330 pound
Oh,
guy.
you bet it is. And so, but then the collision stops these guys really quickly. And if you work it out, the force required to stop these guys in a very short amount of time, like a quarter of a second, works out to be 500-600 pounds of force. Okay, so it's a
It's
huge
enough to
amount of
break some
force.
ribs.
It is, and it's every single play. So it's no wonder these guys get just beat up.
Concussions.
You got to feel real bad for
Yeah.
them.
Yeah. Well, hey, you've got a new way to watch the big game now on Sunday. Set the nachos and beanie weenies aside.
Bananas.
Bananas. You'll make a
Bananas.
lot of bananas.
Right.
Mats, thanks very much. We appreciate it.
More of the morning show next.